This is the Lab 2 assignment of EE542 in the fall semester of 2018 as a part of Internet and Cloud Computing. In this project, we are going to work on a socket programming using DeterLab, building on the previous lab assignment. In this project, we will be using the nodes as a client and a server, and also making some enhancements of our own to learn more about the project, and also adding concurrency by forking into a new process on every request from the client. This is in order to make the client multi-threaded, so that it can listen to multiple clients at the same time and process it at a faster rate. So, the client-server model. This is how most of the communication happen these days, most of the inter-process communication. So for this, we need IP address, port number. The IP address is taken from the host name, and the port number can be specified by us. On the server side, we need to create a socket, we need to bind the socket, and we need to make the socket listen to a specific port number and then accept connections, read from the connection, and write back to the connection. On the client side, we need to create the socket, connect it to the server, read it or write it to the server first, and then read it back from the server. To do this, we have two types of sockets. One is the TCP and the second one is UDP. So the TCP is the Transmission Control Protocol, and the UDP is Datagram Protocol, User Datagram Protocol, or Unix Datagram Protocol. So TCP is more reliable but slower, and UDP is less reliable, which makes the best effort delivery, but it's very fast and just goes as soon as possible when you send the packet. These are some advantages and disadvantages of TCP and UDP. So protocol connection oriented, it takes three-way handshake, and there's no handshake involved in UDP. The header size is more in TCP because of all the added extra stuff, and UDP is just very lightweight datagram. So typical applications of TCP includes email, and UDP includes video streaming and audio streaming, for example, iTunes and YouTube, etc. Before we go over the output of the client-server code, this is the setup which was built on the Lab 1. We will be using the same node setup in DeterLab. We'll have the same nodes, and the communication now is between node A and node B with the IP addresses there. We will be using those IP addresses. And we'll also go over the sample code. This is the server-side code, and these are all the standard headers used in networking projects. And in the main function, we are creating a socket, and then we are setting up the address and the port number here, and port number is taken from the command line argument. After that, we make the socket listen to 5 parallel connections at the same time, and we wait indefinitely for new connection. So we accept new connection, we fork, we create a new process for every connection request, we read it, and then here we read and send back. On the client side, we create a socket using the port number and also by using the host name. So get host by name would be converting the host name to an IP address. After that, we connect, we write, and we read. This would be the output. Let me run the server side for port number 10968. It's running, and we can try here. Client node b dot basic exp e2 dot isi dot net. Oh, I didn't mention the client port number. Yeah, and I send a message. Hi, did you get my message? Yeah, this is a simple client-server model output. We can try it from a different node as well. This is node, by the way, this is node A, node B, node C, and node D. So we'll be sending it again from node D. So client node B dot basic exp dot EE542 dot isi dot DeterLab dot net and 968. Right, so hi, how are you doing? Right, so got it back. As explained in the code before, we are using fork to create new child processes whenever we get a new connection. So the way to do it is PID equals fork. This fork is a system call which creates a new process, and it returns 0 if it's if it's the parent process, and the PID is non-zero if it's a child process. And due to this, if large number of connections are received, it might lead to some zombie processes. And the way to identify these zombie processes is by using this command ps-aux and grep z. Z is for zombies. And now for the enhancement, I have implemented UDP datagram between two nodes, which with a lossy channel. Assuming that there are packets dropped, we are using a go back n mechanism like a sliding window protocol. So in DeterLab, the loss is set to 30%. That means for every 100 packets, 30 packets are dropped or 30 packets are lost on the way. So let me go over the code to explain how this works, and then we can go over the output of the enhancement code. Here we have the receiver side code for the go back n protocol that is implemented. So each packet has a synchronize, acknowledgement, last packet like a fin, a sequence number for every packet. This is used to track every packet which are received in order, and the actual value, and that if it's received or not, and then a CRC to check for errors since it's a lossy channel. So this is like our forward error correction mechanism which is implemented. So the rest of the connection is same. We create a socket, we bind the socket, and we indefinitely accept sockets from that specific address. And once we receive a packet, we perform CRC, and we check if it's a SYN, we send back a SYN packet. If it's a FIN, we send back a FIN. And if it's a sequence number, we check if it's in order or if it's out of in order. If it's out of order, we send it back like a negative acknowledgement, and if it's in order, we send back a positive acknowledgement. And then once all this is done, we print out the message that we got and we exit the program. Now for the sender side, which is probably a little complex. So we have a window size of 5, like a as I explained, a sliding window protocol. The window size is set to 5. So 5 consecutive packets are sent at the beginning, and then depending on the acknowledgements, the next 5 are sent. So we get an input from the user, the text that we need to send. We also set the port number, and we get the host by name. We set the IP address, and then we have the send. What this does is sets a timeout for a packet for the socket here. So every time we send and there's no response within a specific time, we try to resend it. Now this is for the SYN, and then we send packets here, and this is for fin, this piece of code. And whenever we send, we receive to check. And all this logic here is to check if we have the right number of sequence and what to send next. All right, now let's look at the output of the program. Switch on the receiver first. 0968. Server is running, and then let's sender node B dot let me send at least 10 characters. And here we go. So this is what it sent. So for every packet that I send, we are getting the acknowledgement and sending back the sequence number which we need, and for everything it's printing the character that we receive. And this is completely in order, and the total processing time was 0.03 seconds. And finally we received this. Let us try this from another node. Okay. Internet and cloud computing. Send this. We get it here. That's the output of the program. This completes lab 2 of EE542. Thank you for viewing. See you in lab 3 assignment.